Linear regression is a powerful and versatile machine learning algorithm. It is a good choice for many problems, but it is important to be aware of its limitations. Hi everyone, and welcome to Learn to Profit. Today, we're talking about machine learning algorithms, linear regression. Linear regression is one of the most popular and widely used machine learning algorithms. It is a supervised learning algorithm, which means that it learns from labeled data. In the case of linear regression, the labeled data consists of input features and target values. The input features are the variables that we are using to predict the target value. The target value is the variable that we are trying to predict. For example, we might use linear regression to predict house prices. The input features might be the square footage of the house, the number of bedrooms and bathrooms, and the location of the house. The target value would be the selling price of the house. Linear regression model. A linear regression model is simply a linear equation that maps the input features to the target value. The model is trained by finding the values of the coefficients in the linear equation that minimize the error between the predicted and actual target values. Once the model is trained, it can be used to predict the target value for new data points. For example, if we have a new house with a square footage of 1,500, 3 bedrooms, 2 bathrooms, and is located in a certain neighborhood, we can use the linear regression model to predict the selling price of the house. Applications of linear regression. Linear regression can be used to solve a wide variety of problems. Some examples include predicting house prices, predicting customer churn, predicting stock prices, predicting the risk of disease, predicting the weather, predicting house prices. Linear regression can be used to predict the selling price of a house based on its square footage, number of bedrooms and bathrooms, location, and other factors. Predicting customer churn. Linear regression can be used to predict which customers are likely to churn, cancel their subscriptions, based on their past behavior and other factors. Predicting stock prices. Linear regression can be used to predict the future price of. Advantages of linear regression. Linear regression has a number of advantages, including: it is simple to understand and implement. It is interpretable, which means that we can understand how the input features affect the target value. It is efficient, which means that it can be trained on large datasets quickly. Disadvantages of linear regression. Linear regression also has some disadvantages, including: it can only learn linear relationships between the input features and the target value. It is sensitive to outliers. It can be overfit to the training data, which means that it may not generalize well to new data. Linear regression is a supervised machine learning algorithm that is used to predict continuous variables. It learns from labeled data, which consists of input features and target values. The input features are the variables that we are using to predict the target value, and the target value is the variable that we are trying to predict. Linear regression models are simply linear equations that map the input features to the target value. The models are trained by finding the values of the coefficients in the linear equation that minimize the error between the predicted and actual target values. Once the model is trained, it can be used to predict the target value for new data points. Linear regression can be used to solve a wide variety of problems, such as predicting house prices, customer churn, stock prices, risk of disease, and the weather. Linear regression can only learn linear relationships between the input features and the target value. This means that if the relationship between the input features and the target value is non-linear, linear regression will not be able to learn it. Linear regression is sensitive to outliers. Outliers are data points that are far away from the rest of the data. Outliers can have a significant impact on the linear regression model, so it is important to identify and remove them before training the model. Linear regression can be overfit to the training data. Overfitting occurs when the model learns the training data too well and is unable to generalize to new data. Overfitting can be avoided by using regularization techniques. If you enjoyed this video, be sure to like and subscribe to the Learn to Profit channel for more videos on machine learning, artificial intelligence, and data science. Thanks for watching.